In this video, we are going to learn how to solve integral of the form sin x raised to m times cos x raised to n. Here four cases arise. First case, when the power of sin x m is even and the power of cos x n is odd. Second case, when m is odd, n is even. Third, when both m and n are even powers. And fourth case, when both m and n powers are odd. Let us start with the first case, when the power of sin x is even and the power of cos x is odd. We always split the odd powered function and write the rest of function with remaining powers. Next, should we convert sin square x in terms of cos square x or cos square x in terms of sin square x using Pythagorean identity? Let us see what happens if we convert sin square x in terms of cos square x. Then we have the whole function in terms of cos x, and now we won't be able to apply the u substitution because the derivative is not present there. So we should have the remaining function opposite to that of cos x dx. That means the remaining function should be in terms of sin x. So we should convert cos square x in terms of sin x. This way is not going to work. Now we can easily apply the u substitution. We substitute sin x as u and then rewrite the integral. Sin square x get replaced with u squared. 1 minus sin square becomes 1 minus u squared, and cos x dx replaced with du. Now we simplify it further. U squared times u squared becomes u raised to 4 du. Now it's easy to solve. At last we plug in back u as sin x and get the final answer. In second case, the power of cos x is even and the power of sin x is odd. As we know, we always split the odd powered function. So we take out one sin x and write the rest of function with remaining powers. Next, we should convert sin square x in terms of cos square x using Pythagorean identity so that remaining function is opposite to that of sin x. Now we can substitute cos x as u. For such kind of functions, we always split the odd powered function and you substitute the even powered function. Here the even powered function is cos x, so we substitute cos x as u. Now taking derivative of both sides. Here we need a positive sin x dx, so we multiply both sides with negative sign and get sin x dx equals negative du. Then we rewrite this integral in terms of u. Then we simplify this integral little more, distribute this negative sign, and we get negative u squared plus u to the 4 du. At last we plug in back u as cos x and get the final answer. Next, the third case is when both functions have odd powers. So it's sin cube x times cos cube x dx. When both functions have odd powers, then we can assume any of this as u. We can substitute either sin x as u and convert the remaining function in terms of cos x, or we can assume cos x as u and convert the remaining function in terms of sin x using Pythagorean identity. Let us assume sin x as u. Since we assume sin x as u, so we split the cos cube x as cos squared x times cos x dx. Next, we rewrite cos square x in terms of sin square x using the Pythagorean identity. Since we have the single function as cos x, so the remaining function should be in terms of sin square. Now we can rewrite this integral in terms of u. Sin cubed x is u cubed times 1 minus u squared, and cos x dx get replaced with, then simplify it little more and take out the integral. At last we plug in back u as sin x. So the final answer is. And the last case is when both functions have even power. When both functions have even power, then we rewrite them as the whole power, and then we can apply the double angle identity over here. We know that the double angle identity is sin 2x equals 2 sin x cos x, which can be rewritten as sin 2x over 2 equals sin x cos x. And Using this identity, we can replace sin x cos x with sin 2x over 2 whole squared. Sin 2x divided by 2 whole squared dx. Then we simplify it a little more. We squared the numerator and denominator separately. So it becomes sin squared 2x divided by 4. Take out the constant 1 over 4. There is no direct formula for the integral of sin square x. So we need to use the double angle identity. This is the formula for double angle identity. Since we need it for sin squared 2x and the angle 2x get doubled here. 2x becomes 4x divided by 2. So we are going to replace sin squared x with 1 minus cos 4x divided by 2. Take out all the constants. It becomes 1 over 8 outside the integral. Then we find the integral of each term separately. Integral of 1 is x minus integral of cos 4x is sin 4x divided by 4. This is the final answer. I hope you understood this topic now. Please let me know in the comment box on which topic you want my next video to be. Thanks.